26b, combinations of functions, composite functions. We did composite functions earlier. This is the second time we've looked at 2.6. We talked about plugging a number into a function, getting an answer, taking an answer and plugging it into another function. Okay, now we're actually going to be plugging functions into functions.
Yeah, that's
Stegosaurus. So here, this is what a composition of functions looks like. If I have f of x is x squared and g of x is x plus 1, those are two separate functions. I can do a composition of functions f with g by writing it as f of g of x, which means I'm going to take the f function and in place of the x, I'm going to change x into g of x. That's what it means. Now, what is the value of g of x? G of x is x plus 1. So when I say what is f of g of x, I'm saying what is f of x plus 1, which means take the f function, anywhere you see an x, replace the x with x plus 1. So f of g of x using these two functions would be x plus 1 squared. That's all it is. So I took the g function, every x in the f function, I replaced it with the g function. Does that sound confusing or no? Because that's what the f function says. The f function says f of x is x squared. So I changed x to x plus 1. There it is, and it's squared. What if I wanted g of f of x? Okay. It's not the same thing. Because what is the g function? The g function is x plus 1. But I just changed the x to f of x. So I'm going to change this x to f of x. But what is f of x? So I'm going to change this x to x squared plus 1.
So how come on like the first example, the 1 is squared? Like in a parenthesis.
Because I'm taking g of x, which is x plus 1, and put it in the place of x. Okay. Another way of writing that is f of g. That's not fog. Okay. I guarantee every time I see that, I'm going to automatically write it this way because it makes more sense to me. You know how to do order operations, right? First thing in order operations is parentheses. But what if you have nested parentheses? That means parentheses within parentheses. You do the most inner first, right? Folks, it's the same way. I'm going to do the most inner first. I'm going to pay attention to g of x, take that value, plug it into the f function. Questions so far? Okay. It says that the composition denoted as f of g is read as f composed with g. I can pretty much guarantee that I will never use this phrase. That's just not something I'm familiar with or comfortable with. I always read this as f of g like this. Okay. So when you start looking at domains, talk about the definition of composition of functions. This is kind of confusing when you get all the algebra involved here. Tells us that the composition of a function f with the function g is f of g of x, which is the same thing as f of g of x. And if you're listening to this as a recording, it sounds like I'm stuttering almost. F of g of x equals f of g of x. Of course it does. The domain of the composite function is the set of all x in the domain of g such that g of x is in the domain of f. That makes a lot of sense. That's what it says. I know what it means. Okay. So what this means is if f has a specific domain, if I take the g function and plug x into it, if I get an output value for that g of x that's not part of the domain of f of x, then it can't be a part of the domain of the composition. Clear as mud, right? Okay. That's just definition stuff. Okay. Here are three problems. I have two functions. F of x is equal to x plus 2. G of x is equal to 4 minus x squared. And we're going to answer 4 questions based on this. Okay. Letter A, f of g of x. That means I'm going to take the f function, and instead of writing an x here, I'm going to write g of x here, which means I'm going to take the f function, and everywhere I see an x, I'm going to replace x with the g function. The f function is x plus 2. There's an x. What am I going to change that x into? This x becomes 4 minus x squared. So I'll replace x with the g function, plus 2. I've said it many, many times over the years. I've taught several of you. Anytime you plug in, put it in parentheses, right? And I did that. Now, for this problem, do those parentheses serve a purpose? Once you step back and look at it and go, well, those parentheses aren't needed, so let's just ignore them. Ignoring those parentheses, can you combine anything? What? 4 and the 2, right? So writing it in normal form with decreasing powers, what's our final answer going to be? Negative x squared plus 6. And that's it. That's all there is to that. I took the g function and I plugged it into the f function. That's the answer. Okay. Okay. Part B, g of f of x. What am I going to do? Take the g function. Okay, perfect. Which means take the g function, anywhere you see an x, change it to whatever f of x is. Okay, so the g function, 4 minus x squared. So 4 minus, oh, there's an x. That x is going to be x plus 2. Notice I put parentheses around my x. I replaced x with x plus 2. What about the square? Okay. Are those parentheses important? Yes. Very much so. Okay. When you're working a problem like this, be very, very careful. I'm going to keep parentheses when I multiply x plus 2 squared because I am subtracting this product. Okay. And if you subtract this product and don't put parentheses around it, you're going to be wrong. Let me show you what that means. It's 4 minus. I'm going to just not use the parentheses. I'll put them in a minute. If I was to take x plus 2 squared, that's a binomial times a binomial. How do you multiply that? FOIL it. Okay, first times first. X squared. Outside times outside. Inside times inside. 2x plus 4x. Last times last. And folks, that answer is wrong. Okay, the reason that answer is wrong is we are subtracting x plus 2 squared. This whole thing is x plus 2 squared. This whole thing is being subtracted, which means this becomes negative and this becomes negative. Do you see the difference? Be careful. You're going to miss a problem like this on the homework and or the test because you don't put it in parentheses. Okay. Combine like terms, what do we get? Negative x squared. Negative x squared minus 4x. And we're done, right? Because it's 4 minus 4. Okay, there it is. Questions on part B? Part C, g of f of -2 means I want g of f of, not x, -2. How do you work this problem? Okay. Just don't. Just okay. F of -2. That means take the f function, f of -2 would be -2 plus 2, which is 0. Which means I now have g of 0. What does g of 0 mean?
Multiply 4 minus -2.
I want g of 0. You're right. You know, I don't have to write that down, but I am because I want you to see what's going on. So 4 minus nothing is going to be. Okay. Now, I want you to compare B and C. Okay. Look at our answer to part B. It's not all there. There it is. What is, so we're saying, we got this answer here. Let's take this -2 and plug this -2 in here. What is -2 squared? Right? So -2 squared is 4, but there's a negative sign in front of it, so -4. And then I have a -4 times -2. And -4 plus 8 is? Which is the same thing right here. Okay. So if I'm asked a question, what is g of f of -2? Folks, I'm doing it this way. Okay. But let's say I've got a set of problems that I have to do. I want to know what is g of f of -2, what is g of f of 6, what is g of f of pi, what is g of f of, you see what I'm saying? A whole bunch of times. I'm probably going to do it this way and plug all those numbers into that. Does that make sense? So it just all depends on, you know, where you're headed. Okay, how about part D? F, huh? Why? This means f of x. That's all it means, right? Which means I'm going to take the f function, and every time I see an x, I'm going to replace it with the f function. No, it's on, this is it. So here's the function. Here's f of x. There's an x. What am I going to replace this x with? Plus 2. Question again. Are those parentheses necessary? No. They're there because we use them to plug stuff in, and then we can evaluate it if they're needed or not. Okay? X plus 4, and we're done. questions so far? Is this a bad section? Pretty simple section?
Seems too easy.
Too simple and we're gonna run into something.
Okay, so I'm just gonna go through these. Here they are worked out. Here is the letter A. So if you're doing screenshots, great. You've got this document in your Google Classroom anyway, but there's that one. Here's part B. Same answer that we got. Here's that note. F of G and G of F were not the same, were they? G of F, we got x negative x squared minus 4x. F of G, we got x squared plus 6, so they're not the same. Okay. And here was part C. And there is no part D because I wrote that in myself. Because I did it. Good question, though. Okay, decomposition. Decomposition means I've got a ugly equation that's got equations within it. Can we take it apart? Okay. Can we take an equation from the inside, pull it out, and have another equation there? This is done in calculus a lot. Okay. So I've got this function h of x. H of x is 3x minus 5 cubed. Okay. Drill on the inside. What is the most inside function that you see there? Go on the inside. What do you see? Do you see a 3x minus 5? Everybody sees a 3x minus 5? Okay. If I took out a 3x minus 5, what's left? Okay. The x. So here's what's happened. H of x is what happens if you compose f of x and g of x. So if g of x is 3x minus 5 and f of x is x cubed, then h of x would be 3x minus 5 cubed, which is g of x. 3x minus 5 is g of x, right? G of x cubed. So f of g of x. So it's going backwards. There is not a correct answer to a decomposition because it's possible that you see it differently. Someone might look at this and say, well, I see a function right there. If I said f of x equals 3x, is that a function? I'm not going to use f or g. Let's go with a of x. I'm going to say that a of x is equal to 3x. Can y'all see that?
Yes.
So if I replace this, that would be an x minus 5. So I could say that b of x is x minus 5 cubed. And by writing it this way, can you see that b of a of x is equal to 3x minus 5 cubed? Is that the same? If I take this b function and replace x with 3x, do I get this? Okay. Now, which one is the easiest to see? The one that they showed or the one that I did? There's a minus there, right? Yeah, the one they showed. They showed the obvious one. Obviously, 3x minus 5 can be considered a function. And if I take 3x minus 5 and cube it, that's what's going to happen here. Okay. So that's how decomposition works. Start on the inside, find a function, pull it out, replace it with an x. There's your another function.
That seems really easy.
Okay. This will mess with your mind.
Yeah, my brain is-
This will definitely mess with your mind.
This is on the homework. How is it gonna be known if it's correct?
Oh, when you press that submit your assignment, it says a check mark, it's right. If it puts an X by it, it's wrong.
Well, thanks, Captain.
You asked the question.
Yeah, but like if there's multiple ways to put it, how do they know which one's correct?
I'm going to assume they're going to go with the obvious one. I mean, I haven't played with the homework. I might play with the homework in a little bit and try different answers and see if it accepts them both. A lot of times that's true. Yeah. I'll play with it and look at it. So basically, to decompose a composition function, look for the inner function, look for the inside, for that obvious piece, look for that 3x minus 5, take it out, make that a function, and then the outer function is going to be your other function. Word problem.
If we can just
Really
stay there
hard.
for 5 more minutes, I don't have to do it.
Bacteria count. I've got a function here that says n of t is equal to 20 capital T squared minus 80 capital T plus 500. My domain for this is T is between 2 and 14. Capital T represents temperature in Celsius. Okay. When the food is taken from the refrigerator, the temperature of the food is given by capital T of lowercase t is equal to 4 times lowercase t plus 2, where t is between 0 and 3. We're taking food out of the refrigerator, 3 hours. How much bacteria is going to grow in 3 hours? That's what's going on here. Okay. So letter A, find the composition n of capital T of lowercase t. Means what is n of t of t? Okay, what's the main function that I'm using? Capital N of t. So I'm going to take the capital N of t function, and anywhere I see a t, a capital T, I'm going to replace it with the capital T function. So 20 times, here's a t, but t is 4 little t plus 2 squared minus 80 times 4 little t plus 2 plus 500. Are those parentheses important?
Yeah.
All of them are, aren't they?
Yes.
Okay. Okay. This 20 is being multiplied by this product, which means when I FOIL 4t plus 2, I'm going to leave it in parentheses because that whole thing is going to be multiplied by the 20, just like the negative a while ago. Okay. So I have 20 times 4t plus 2 squared. First times first. Plus outside times outside. Inside times inside. 8t plus 8t. 16t plus last times last. Distribute the negative 80. So minus 320t minus 160 plus 500. Everybody okay? Okay, bless you. Next step. What should we do? Okay. Anything else? Okay. Can we do it all at the same time? Okay, so we have 20 times 16, 320 t squared plus 320 t plus 80 minus 320 t plus 340. Not doing anything illegal, right? Okay, combining like terms.
Give you 320t squared plus 4. That's approximately.
These guys cancel. Plus 420. Okay, so I now have N of t is equal to 320t squared plus 420. What's that mean?
That means N, they'll grow 320 bacteria.
What does N represent? What does N represent? N represents the number of bacteria. Capital T represents temperature, but temperature depends on time. So this ultimately means the number of bacteria depending on the amount of time. See that? Okay. Part B, find the time when the bacteria count reaches 2,000. Where's the 2,000 go?
2,000 equals 320 t squared plus 420.
Perfect.
And then solve for t.
Okay.
So we could change the variables if we wanted to, right?
I guess you could. I like them the way they are because they're meaningful.
Well, I don't like the t's because they all look like pluses.
That's why my T's have tails and my pluses don't.
Yeah.
Okay. What would be the best method to solve this? Is there a T term? There is no T term, is there? There's only a T squared. So because there's a T squared, the best way to solve this would be taking the square root, doing the square root method. Okay. So let's get T squared by itself. Step number 1, subtract 420 from both sides. What happened to the what? It's right there. That's not T squared. Those are just, that's a positive 320T and a negative 320T. They cancel each other out.
I did the same thing. I didn't see the negative signs. Yeah, because there's so many.
Okay. Subtracting 420 from both sides gives us
1,508.
equals 320T squared. Next step.
Divide by 320.
Okay. So I have T squared equals, what is 1,580 divided by 320?
4.9.
Give me the whole number. Okay. How do I get T by itself? Okay. Folks, I'm solving a quadratic here. When I solve a quadratic, how many answers am I going to have? Okay. 2, right? Plus or minus. And I'm going to change this equal sign because this is not going to be pretty anymore. I'm going to change it to approximately equal to. And what is the square root of 4.9375? 2.222?
Yeah.
I'll leave it right there. Okay. What does lowercase t represent? Time. You tell me, when is the time going to be negative 2.22? Never. We throw it away. Okay. So how much time is it going to take to reach 2,000 bacteria?
Don't we just plug 2.22 into 320? Oh, I'm sorry.
So let me ask this again. How much time is it going to take to have 2,000 bacteria? About 2.22 hours. Okay.
Oh, I forgot about that.
Okay, yeah, it would take, it's gonna take about 2.22 hours or about 2 hours and,
In
I don't know,
9 minutes?
I don't know how many minutes that is.
Well, I divided it and it's 11 out of 50, the 0.22.
Okay. What you think?
A lot, but I feel like it's easier than I think this is the easiest thing we've ever done in my whole life.
Like, in theory, it sounds easy, but like actually doing it.
Okay. So here's the book working it out. For those of you that are doing screenshots, this is exactly what we got.
I think this is the first thing I fully understood easily.
Here's your answer. Note when you solve the equation, you reject the negative because we don't have a, the original problem said t had to be between 0 and 3, right? So that told us the domain was between 0 and 3 hours, is negative 2.2 between 0 and 3. So it's rejected. It's not part of the domain of the problem.
Could you ask questions and stuff, and Parker always answers them, because he's so far back, no one hears him, so it's just dead silent, and then someone else will answer over him.
Oh my
Okay.
gosh. That probably does happen, but
And that's really, I mean, that's all at 26B. Let's do number 3 on the practice real quick though. Ugh, stop it. I want to decompose number 3.
yeah, I could do this if there wasn't.
Okay. What function do you see on the inside? So here, what this says right here is f of g of x, right?
Yeah.
So what's on the inside?
G of x equals x squared minus 7.
Okay. So what is f of x going to be? Basically, think about it. I'm taking out the x squared plus 7 and replacing it with an x. I'm working backwards.
The cubed root of x.
That's it. We're done.
That seems blue.
Okay. Inside out. Inside out. The only thing we do in this class is easy stuff.
That's not true. I got all hundreds last 6 weeks, except for the military class. Dude, my elective is the only class that was hundreds. She makes up grade. They're made up.